This is the problem about the helicopter and the Jeep, and this is a clip art that I found, so this one is not exactly a Jeep. Oh well. A helicopter is lifting a 2,100 kilogram Jeep. The steel suspension cable is 48 meters long. It's actually in the neighborhood of like 150 feet, so my scale is somewhat off here. And has a radius of 5.0 times 10 to the negative 3 centimeters. I'm sorry, meters, which is actually pretty small. That's 0.5 centimeters, so just 1 centimeter, or about 2/5 of an inch, maybe like a quarter, a little bit more, like 3/8 of an inch in diameter. Excluding the arm, the mass of the gymnast is 60. I'm sorry, reading the wrong problem. Find the amount that the cable is stretched when the Jeep is suspended motionless in the air, and B, what is the amount of cable stretch when the Jeep is hoisted upward with an acceleration of 1.5 meters per second squared. So we're supposed to figure out what delta L is. We have given L0, which is the length of the steel cable. We have given the mass and therefore the weight of the Jeep. We have given Young's modulus. It's in the book for steel. And we have given the cross-sectional area because they also give us the radius of the steel cable. So that follows from that. There was supposed to be an arrow. And that follows from that. And so we're going to use the equation for stretching and compression. So we're going to have F equals Y times the strain, delta L over L, times the cross-sectional area, and of course we do the algebra on this one, so delta L, it's an L0 actually. So delta L is going to come out to, everything's just being multiplied with each other, so Fy, F times Y, Fw, times Young's modulus, times original length, times area. Okay, and this must be late in the evening when I'm recording this. Boy, I haven't done such an algebra error for quite some time. This is going to be F times Fw times the original length divided by Y, Young's modulus, and the cross-sectional area. I guess that wrong algebra a moment ago just looked appealing to me. And then we come up with by how much that steel cable is being stretched, as it's just simply holding on to it, as the helicopter is simply holding on to a Jeep. Of course it's going to be in meters. It's in the neighborhood of like a couple of inches or so when you come up with that in meters, of course. So it's not negligible, because the weight is quite a bit. I mean, 2,100 kilograms, or almost 5,000 pounds hanging on it. Okay, part B, the equation that we need is going to be virtually the same. So let me see if I can copy this one here. As I said, virtually the same, not exactly. And I hope I'm able to pull this down here. But I need to do something first. First of all, I'm going to take this one off here, and I know that I have to get rid of that W. However, in part B, it says that what is the amount of cable stretch when the Jeep is hoisted upward with an acceleration of 1.5 meters per second squared. So what we have now is we also have an acceleration up. That means that the helicopter exerts a force on the Jeep. So contrary or in different, what's different to the first part of the problem is where we plugged in simply the weight, because it's the only force that is pulling on the steel cable. In this case, it's the weight that is pulling on the steel cable, but at the same time the helicopter is also exerting an extra force on it in order to accelerate it upward, which means we can imagine that the force that is now acting on the steel cable is more than before, and therefore the stretch is also going to be more. But this is the way to write it down. This would be the force of the helicopter pulling it upwards, and then this one here is the weight of the of the Jeep, and that in the previous problem, the previous part of this problem here came out to 0, and of course the weight is pulling down, and that's why simply this force here with which the helicopter had to pull up is the weight, and that's what I plugged in. Now in the second part of the problem, that's not true anymore. We don't have a 0 on the other side. We have mass times acceleration, and we know that this number here is positive, and of course over here this is minus because we have to subtract the weight. So we do one algebra step and we come up with that the force that the helicopter now needs to exert is equal to the weight of the Jeep as a positive number. This one here is positive as well, plus the mass times the acceleration with which it is accelerating it upward. And so we have here the mass, which was 2100 kilograms, times 9.8 plus an extra 1.5, and that now will be the force over here. So the delta L is going to come out slightly larger in the neighborhood of like 3 inches or so.